Alright, so the easiest way for me to do these updates is just to keep doing video updates. I'm just going to put this in here. So I got the controller wired up. We have the relay circuit running here, wired up to the controller, and if we see that little blinking light, if I zoom back here a little bit, we can see that every time that light lights up, we're also performing a rotation, which is right now roughly a quarter turn. And honestly, I thought I had it working pretty well at first, but once I started testing it a little more harshly, I realized that we weren't quite on the mark. So the original code that I had in the test that I was doing used a delay. So I would tell it to wait for 500 milliseconds, activate the relay, and perform a turn, and do that for 500 milliseconds, and then halt and wait for another second. And so it would just turn, stop, turn, stop. But it turns out that the delay code for the Arduino is extremely inefficient. It was a combination of the delay as well as the call to write out to power this pin here. If I zoom in, pin number 13. So I'm now writing to the pin to get power out to the relay in a lower level manner, as well as using a different way. Rather than telling the system to delay for a certain amount of milliseconds, I'm accumulating time and counting milliseconds myself, and when it hits a certain point, either starting or stopping the turning process. Unfortunately, that still seems to not be accurate enough, at least for what we're seeing. The goal really is to get this to basically be able to have a hard limit of, say 90 degrees. And we want to turn 90 degrees, so it's 90, 180, 270, 360, 90, 280, 170, so on and so forth. But I haven't got that to work, not only in 5, but I also tried it in CE, and it didn't work. So I'm going to play around with the code more and see if I'm doing something super inefficient to cause the latency, or if that's not the case, then I'm going to have to either upgrade the piece of hardware on the Arduino that keeps track of time. From what I understand, it's a ceramic resonator, which is a lot more susceptible to getting off. It's possible I may be able to calibrate the timekeeping hardware and do some calculations in software to adjust it and get accurate millisecond counter, or I might just have to buy another piece, a small real-time clock that incorporates a real crystal, so that I can get an accurate timing. Unfortunately, the way MIB 2347 was doing his test before, where it was the relay was wired up to the vibration, we were getting succinct, hard, common. I honestly believe now that he did not have an issue where there was any wavering in the signal that was coming from the rumble. But unfortunately, I thought that I was going to get a more accurate timing, and it seems that that's not the case, and we're just going to have to do a little more work to get that accurate timing. But we're a little bit further along here, so hopefully I can either figure out in code in the next day or two, or just order a few more parts and add a little bit more complexity to this circuit, but enhance the Arduino a bit, and we can keep this thing going.